Alright, so we're going to start by writing our given quantity first. So for this one, our given quantity, guys, is going to be 26 centimeters. Alright, now, anytime you are going from the metric system to the customary system, you're going to have only one conversion that I've expected you to memorize, and that's that 1 inch is equal to 2.54 centimeters. So you should know you have to get there. So I have to get from centimeters to inches, and then can you get from inches to feet? Yes, so that tells us our first step is going to be getting out of centimeters. Remember, this is like saying 26 centimeters over 1. So it's much like in math class when you have x over 1 times 1 over x. That's equal to x times 1 over 1 times x, right? So the x's cross off. Trying to make parentheses there. And that equals 1, right? That's what we need to do here. We need to take it times 1 so we can get rid of centimeters. So what do we want for a unit in the bottom?
Centimeters.
Exactly. And we know that there's 2.54 centimeters in 1 inch. So we write 2.54 centimeters.
Inch on top.
And 1 inch on top. So my centimeters cross off, and I'm in inches now, but I want to get to feet. So now what do I need to go in the bottom of my next conversion factor?
12 inches.
Exactly, because I have inches on top, I need to know that there's 12 inches in 1 foot. Remember, this only works if that is an equality statement. The top is equal to the bottom, so I'm technically multiplying by 1. So 12 inches is equal to 1 foot. Now my inches cross off. I'm in feet, which is what I wanted to be in. Now, I'm going to show you how mathematically it makes sense, so you can just multiply by what's on top and divide by what's on bottom, but my screen's going to look kind of crazy to start with. So if we take all of the numerators and multiply them together, so 26 times 1 feet.
26.
Okay, and then I've got 1 times 2.54. It's hard to write small and fine with this. Times 12. So it's 26 times 1, and my unit's feet. So 26 over 2.54 times 12. But remember, multiplication and division has a unique property that you can do them in any order. Do you remember what that's called?
And what does?
That's the order of operations for all operations. But multiplication and division have special property. It's called the commutative property. Have you guys heard those yet? Yeah, so it means you can do them in any order. So I'm going to do it in the order that this is like looking like we should normally do. So we do 26 times 1 times 1. Okay, right? That's our numerator. And then we're going to divide that by 2.54 times 12. Okay, I'm going to get 0.85. There's me being dyslexic again. I get 0.85, and it's a 3 next, so when I round to 2 sig figs, it rounds to 0.85. I'm going to write it up here a little better. And then my unit is feet. It's the only unit left that I didn't cross off. Okay, and you can say 8.5 times 10 to the negative first as well. Same thing. Alright, now, if we were to type it in our calculator, remember, we're practicing on a calculator you would use on a test, so we don't have any, I don't know how to use a calculator moments. If you were to take 26 divided by 2.54, enter, divided by 12, see that you're going to get the exact same answer. The ones don't change anything. So again, if you just take 26 divided by 2.4, enter, divided by 12, enter, it works. So from here on out, I'm going to say multiply if it's on top, divide if it's on bottom. Okay?
Wait, so what about the 26? That just gone to
It's what you start with. So you'll say 26, and then divided by, you take 26 divided by 2.54, enter. Then I take that quantity divided by 12, enter.
Oh, okay.
Make sure we're practicing on a calculator we would use on the test. Okay. The whole class, nobody's really typing here. Guys, this is where it gets more dicey, is because we got to do it in the right order. So then the answer for that one was feet. And then 8.5 times 10 to the negative first feet would be the other answer. And always circle or box your final answer. Okay, go ahead and try the next one. See how far you can get.
We take a shortcut on a test, we get docked for it.
So if you get the number and the answer completely correct, I won't even look at your work. But if it's a 10-point problem and I look at your work and I see nothing and you have nothing correct, you get 0 out of 10 points. It's your gamble.
You know how Mr. Wright used to. She's that wrong. I was the more work that you show, as long as you work it right, you'll support.
And literally, like, if I can see what you did wrong, so you just flipped one conversion factor and there was like 10 of them in a row, you'd miss half a point out of 10 points and still get a 9.5 out of 10 and you'd still get an A on that problem. And rather than missing the whole thing.
I would say that you're
How much? Well, where 1,000 grams and 1 kilogram?
No, you can or you can just do the decimal.
Where grams? A gram is a base. How do you use it in and out of it?
You want to do this out?
So like 6 pounds.
Yeah.
Like 8 pounds.
Alright guys, can I show you something really quick before you go? I think a lot of you are like, hey, we're going from a weight to a mass. That feels weird. Okay, I'm going to tell you why. First of all, it's reviewing some of the stuff we should know about units. We should know that in the US, if you're measuring mass, what unit are you in? Remember, we had to look it up? You never heard it?
It's like something.
Slugs, remember? How many slugs are you, right?
4.
You're like 4 or 5, like somewhere around there, slugs. In the metric system, if we're measuring mass, what's our SI base unit? Someone back there was schooling us on it. Who was it? The SI base unit for mass.
It's kilograms.
There you go, yes. Kilograms. Kilograms is the SI base unit, but you should know that 1 kilogram is equal to 1,000 grams because of the King Henry died by drinking chocolate milk. You can't see that. 1 kilogram, oh boy. This worked way better the other day. I don't even know what's going on. There's 1,000 grams in 1 kilogram. So kilograms the big guy, grams are the little guys. Okay, now weight in the US, every listen, is pounds. And the metric system is what? Newtons, right? Volume in the US, in liquids, we say fluid ounces. This is not writing pretty at all. And for solid, we'd say cubic feet. And the metric, liters and cubic meters. The reason I'm showing this, guys, is they have you go from pounds, which is a weight, to grams, which is a mass unit. And the reason you can do that is because you're on Earth. You're not changing your gravitational force, so it's the same. Okay, that's why there's a conversion factor for it.
But if you were to go from pounds to grams, you go pounds to grams, you could do that.
That's
the taking.
What you'd have to do is you'd have to figure out what your grams are on Earth, and then you could figure out it's the same on the moon. So your mass stays the same. Your weight would be 0 on the moon, though. And not the moon. Your weight would be a sixth of what it is here.
Yeah. Maybe that's an pencil.
Well, I haven't. I did try. It's still running.
Oh, I'll be like it.
I don't know why it's so.
Yeah, I think that's right.
Yeah, it's
Why?
Yep. Oh, years. It's in length, right? So years.
Why aren't they? That's
Oh, that's yards to second. Oh, years to second.
Alright.
Sorry.
0.54 10 times.
This is usually how I'll help you with paths, guys. We're gonna go pounds to kilograms, kilograms to grams. There's another path, but it takes longer.
7,000. I get this right.
You ever thought about teaching this extended chemistry?
I actually used to teach like an extended physics, but it's the same thing that you learn in freshman year, so it felt redundant.
What have you got for no answer?
I don't have an answer for you.
Sorry.
Very
You're good.
I'm sorry.
I'll do it. I'll work it really quick. I was gonna see if this works as a stylus. I have a new stylus coming. I think it'll help. Okay, so we know 1 pound goes on bottom, and then 0.454 on top, and that's kilograms.
That's what I'm gonna.
And then we know in 1 kilogram, there's 1,000 grams.
I actually got it.
Remember, every time you double check, sorry, do I have a unit on top and bottom? Top and bottom. Did I end with what I wanted to end with? And are each of these actually an equality statement? Meaning, does 1 pound actually equal 0.45 kilograms? Does 1 kilogram actually equal 1,000 grams? If those are all true, then you are right. Like, or unless you typed in your calculator wrong. So I'll take 16 on my calculator. And I'm going to take it times 0.454. And I like to hit enter. That way I don't like fat finger. And I only have one chance of doing it. I'm going to hit times 1,000. And you should get, I'm going to write what my calculator spits out at me. It's 7,264 grams.
See, I got that, but I did some right there.
There was another path that you could have taken.
0.454 times 16,000.
Well, okay, that,
Oh, never mind. Yeah, then I got 7,264.
but why?
I don't know how.
I bet he took 16,000 first and then did that all.
Right.
I just was on the spinner.
But that's not always going to be a good gamble, right?
It's not a good.
No, it's not a good gamble. I mean, you did the same math we did. You just didn't have logic behind it.
Oh, I just finished simpler.
Oh, no, I have the same answer.
This is a really simple conversion, and when we're talking about atoms in a certain amount of a substance, you won't be able to make it simpler. Make sense?
Yeah.
Like if I'm asking how many atoms are in 12 grams of sodium chloride, like, and you have to go from formula units. No, the other way is because there's it also says 1 pound to newtons. You could have
So
gone
would it be
that way.
7,300 then for your 16?
Yep, because you only have 2 6. The only one that matters is your given quantity, and I only have 2 in my given quantity. So I have to round to my second digit here. Look to the right, I have to round up. So it's 7,300
Oh, shoot.
grams, or 7.3 times 10 to the third grams. And always circle back to your final answer. That way I can find your work. Again, we're learning this skill and stuff that we can see conceptually, because we're going to use it on stuff that doesn't make so much logical sense.
40 years to seconds.
Yeah, you got it.
How many years are there?
How many seconds are? 40. Tell me how many seconds are in here and I'll figure it out.
That would be very good.
What do you think on this one, guys?
1 year to.
You gotta take times 365 times 60 times 60.
Yeah, so a lot of times people want to go to months. Why is months not a good option?
Because there's different
dates.
Yeah, it's really inconsistent. I mean, we have a leap year, but it's relatively consistent, right?
But a year is 365 days and 1 4, so.
Yeah.
Took me another week, people.
I would not. I would go straight 2 days. Weeks isn't always the easiest to remember, is where I would go with. Days, people should know, at least. And I'm going to use 365 instead of a quarter, just because I don't want to even talk about a leap year with kids. But yes. Alright, so we've got years to days, days to hours, hours to minutes, minutes to seconds. We're just breaking it down simpler and simpler. Why do you think you should actually record 1.00?
The now.
Yeah, so if you just write 1, you might accidentally only round to 1 sig fig in your number. And down.
I'm looking at a big number.
It should be logically, right, if you look at it. Does it make sense? There's a lot of seconds in a day, in a year.
Correct?
Yes.
3 6
So we're looking at 3.35. Oh, yeah.
Days, hours.
1, 2, 3, 4, 5, 6, 7.
My thing was like not catching so much last time.
Is 7's an S? I thought it was SEC.
In science, we tend to abbreviate with an S. Like, generally speaking, people go up. Multiply really what's on top, divide by what's on bottom. So I'm going to type 1. You don't have to, because obviously I'm going to change anything. Times 365. Times 24. Times 60. Times 60. And I get 315,360,000, right? Let me see. 31 million, right?
31.
Yeah, 31,536,000. Yep, so 31,536. Yep.
Is that 31?
31,536,000. Not yet. I haven't done sig figs. I'm just showing you what my calculator says because you got 1, 2, 3 sig figs. So you go 1, 2, 3. Look to the right. I'm gonna stay on that. So this gives me 3.15 times 10. I'm gonna move my decimal 1, 2, 3, 4, 5, 6, 7. Okay, guys. Look here, another common mistake is people mistake their seconds as a number, and they magically end up with another exponent that they move past. Okay, so be careful when you're writing your unit that seconds can look like a number and throw people. Also make your decimals really, really obvious, because sometimes they forget to see them and don't type them in their calculators. Like, kids would type 100 on their calculator and forget. Okay, so another common mistake. So 3.15 times 10 to the 7th seconds.
3.5 minus 4.
Go ahead and try number 11.
Wow.
No.
Oh, yeah. There's what? 3.5 to 5 o'clock. Wait, why does my clock go down? They probably think I do. To inches, to centimeters, to meters, to kilometers, kilometers.
What makes you feel any better? It's my 3rd time doing it today, but like my 100th time doing it.
Oh, it's not like 5.
Well,
It's pretty close.
But we're gonna be a little more precise, so we're gonna use sig figs. Let's do it. You can do it. I have faith in you.
I say. Nick Stein did the whole worksheet that he got today, and he didn't know that there was an answer key on the back.
He probably wouldn't have looked at it anyways.
Yeah.
Right, until he got
He got the
done.
whole thing done and was like checking his answers. And then I was like, is there a backside to that thing? He goes, I hope not. And he turns it over and he's like, oh my gosh.
I said, not tell anybody, so don't tell anybody. Shh.
Oh.
Shh. I wait for them to find out. It's always fun to see how it eventually trickles through. Like, you already know you don't have the worksheet, though.
Oh, so I wasn't supposed to tell the whole class.
Shh. They don't know what you're talking about. Shh.
Do you go from inches to centimeters?
Yep, anytime we are going from the metric system to decimal or vice versa, we have to use that conversion. Remember, that's the only one we're going to memorize because it's the most precise. I can't write small enough for this.
You go from centimeters to meters to kilometers.
That's how I would do it, yeah.
1,000 to kilometer.
Yeah, I thought you were talking the first one. I'm like kind of angle here because I'm. Yep, there's 100 centimeters in a meter, and 1,000 meters in a kilometer. Remember when I was doing this as a review for AP Chem and you guys watched and you're like, this isn't our worksheet, is it? This was the problem.
The same problem.
Yeah, you can do it. See? Oliver, what'd you think it was?
Close enough.
Take it.
So, while we know that for every 1 mile there's approximately 1.60 kilometers, obviously that is not down to a centimeter of precision, much less a hundredth of a centimeter of precision, right? So this is much more precise. Look how smart you feel.
Oh, it's hard.
Look how smart yet. Oh, what'd you miss?
I don't know.
Did you show your work well enough so you can see it?
I did.
See?
I'm at
You win.
25 miles. 5,300.
I got 5.6
for you.
I got
Right
5.6.
here. There's not 1,000 centimeters in the meter.
There's 100 centimeters in a meter.
Gotcha.
I know it's kind of hard to read my handwriting up here. I got a new stylus coming. Hopefully it looks better.
Would that
I'm gonna
be
reach
changed
out
to
for
the
a
top?
Always on a quiz or test, type your numbers in twice. If you get the same thing twice, then you should be good. But as long as your numbers are right.
That would. I got 5.6.
Let me look.
5.6.
It could be 5.6. I could have fat fingered. Hold on. 3.5 times 5280 times 12 times 2.54. It could be. Yeah, guys, it's 5.6. I fat fingered something. Divided by 1,000. There you go. 5.6.
Eli.
Still right.
Oh, I can't erase. Darn it. Sorry, guys, I can't erase. It's 5.6.
Janine, however, could make it correct. It was this thing. He got
an error in mine today, too. I'm not against you guys hollering at me. I get tired of doing these. I've done them so many darn times that I just
Hey, yeah,
Just trying to get through it. And
spent out of power.
one of them was wrong.
It was the one with this X square. Or not square cube.
X cubed.
X cube.
Alright, guys, let's see if we can do this one. Let's see if we can do this one, guys.
It says don't freak out.
Don't freak out. I usually give this to, remember I give this to freshmen. This was originally my freshman worksheet.
This is crazy. What?
I challenged them a little more.
Alright, brother.
We can't do this.
we were not.
Come home.
So you go miles to
Your sister had me.
Freshman back in the
As a
day.
freshman?
Do you have this?
You go miles to meters in hours to seconds?
Yes. I always had good enjoyment of throwing like a physics problem on my physical science test, and there was always this one kid who figured it out despite like something small.
Yeah, I'm that.
Like for bonus points?
Yeah.
Okay, must do.
Need to be that guy.
Yeah, myself did not do any.
Are you done? I just don't know what to do because I think I did it wrong.
So guys, your plan of attack on this one is going to be you're going to start with the 3.5 miles and 4,000 meters, just in the previous prompt, we stop one short, right? We just don't have to go kilometers. And then what you can do is you can just line up hours to seconds and just keep going. But is hours on the top or the bottom of the factor? The denominator. So you're going to have to put hours on the numerator for your first conversion. So just flip it. You can do it.
Is this right?
It'll make you look so smart when you're done. Right.
I just don't, I didn't think it. You only got 3.5, you're not covering 15 meters exactly.
So is it 56.327 meters?
I don't remember.
No, it'd be 560.
What?
For me, the errors my kids usually catch is I start flipping numbers around there side by side. I get real dyslexic when they get bored.
5,000.
That's fine.
I got 15.
I'm gonna do it. I don't remember everything, Mr. Key. Alright, so we'll start with 3.5 miles over 1 hour. I'm gonna run out of room.
Oh, I got that one right.
Alright, in 1 mile, there's 5,280 feet. 5,280.
Oh, 3.7.
In 1 foot, there's 12 inches. In 1 inch, there's 2.54 centimeters. We're gonna have a quiz over this first. But the test isn't far behind it because this is the majority of the chapters, like this and then physical and chemical properties. There's 100 centimeters in the meter.
Wow, that's where I went wrong.
Okay, now you double check. Miles on top, bottom, feet on top, bottom, inches on top, or bottom, centimeters on top, and bottom. I'm in meters like I wanted to be. Okay, now I gotta get my hours to seconds. You can just literally line them right up. I have hours on bottom, so I need 1 hour on top. And to go smaller, I know there's 60 minutes. Hours cross out, but now I need to get from hours to seconds. I have minutes on bottom, so I need 1 minute on top. 60 seconds on bottom. Minutes cross off, and notice how I have meters on top and seconds on bottom.
Wait, so you don't just go to another row and start.
Does it change anything if you do it on like completely separate?
Nope, you could literally just do like 3.5 and do that first one. That one, do the first one. The only thing is don't round until the end, because that's just my rule. Like, different teachers will have different things in college. Tends to be that chemistry teachers tend more towards doing rounding at every calculation, whereas physics tends to round at the end. But for me, I just do across the board, wait till the end and round. So I think it's redundant to do it 100 times the problem. Okay, so for me, I'm just wait till the end and do your sig figs. So when you're done, round to 2 sig figs. Keep it all in your calculator. Okay, so we're going to do 3.5 times 5280 times 12 times 2.54 divided by 100 divided by 60 divided by 60, and you should get 1.6 meters per second.
Holy crap, man. Somebody caught me out of line.
On that last one, or what was the last one? Oh, 5.6 and 1.6.
Oh, God, so I put that as 0. Hey, Albert Einstein made a mistake, I guarantee you.
No.
Alright. 2 sig figs. Remember, it has to be 2. You can have more, you can have less. We will have identical answers every time. That's kind of nice, right? I like it. I like certainty. That's why I like math and science, is there is one right answer. It's not like English. Someone just made it up and we have to follow it. So, it's nonsense.
What's the point in math for everything and stuff?
You feel that way because you don't see it in nature yet. But like all math, like literally the entire... Okay, I'm not into that. Or matrices, I'm not about that. But like, calculus was literally based on motion.
I'm more
crazy is
talking
that?
about imaginary numbers. Like, why can't
Yeah,
you-
that's not my happy space.
Yeah, that was a new time.
This was my couple of that unit to go with this is pointless.
My gut feeling is that.
Imaginary numbers. So you guys should have.
I'm gonna shut the camera off before you keep saying that stuff.
Oh, put the camera on.